So for relative velocity, the velocity of a particle relative to reference frame S is equal to its velocity relative to reference frame S dash plus the velocity of the reference frame S dash relative to S. So let's take the example of a boat traveling in a river. So the velocity of the boat relative to Earth is equal to the velocity of the boat relative to the river or water plus the velocity of the water relative to Earth. And you can find details of the relative velocity in the book in the bio, which is available for free. So suppose the water waves are moving to the east at the speed of 3 meters per second. So the magnitude of the water waves relative to Earth is 3 meters per second. And now suppose the boat wants to cross the river with an aim direction north. So the velocity of the boat relative to the water, suppose that it has a magnitude of 4 meters per second. So to the river, the boat is moving forward north. So let's see how the boat moves relative to a stationary observer on Earth. So from vector addition, you can see that this vector here is the velocity of the boat relative to the Earth. So an observer stationary on Earth will see the boat drifting east of north. And from vector addition, you can find this direction theta of the velocity of the boat relative to Earth, and you can find its magnitude equal to 5 meters per second. And tan theta, which is equal to 3/4, will give theta equal to 36.9 degrees east of north. So now let's see what happens if we have the same situation where the water is moving relative to Earth in the direction east, where the magnitude of the velocity is 3 meters per second. And now suppose that the boat has an aiming angle of around 48.6 degrees west of north. So this is the velocity of the boat relative to the water. And suppose it has the same magnitude as before of 4 meters per second. Then from vector addition, you can find that the velocity of the boat relative to Earth is directed north and will have a magnitude of around 2.65 meters per second. So when the boat is steered at this angle, then relative to a stationary observer on Earth, it will move north. So now let's suppose the boat is steered in the same direction of the river. So the velocity of the boat relative to the water has this magnitude directed east. So this is the total vector, the addition of these two vectors, which is equal to the velocity of the boat relative to Earth. And it will have a magnitude of 7 meters per second directed in the same direction of the river. So now suppose that the boat is aimed in the opposite direction of the river with the same speed of 4 meters per second. So the vector addition gives this vector, which is the velocity of the boat relative to Earth, which has a magnitude of 1 meter per second directed west. So of course it would be moving slower in this direction and faster when in the direction of the river.